Hi, my name is Jake Peterson, and I will be demonstrating to you today how we determine and calculate weight and balance on an aircraft. Before we get into that, there's a few terms that I'll have to cover with you so that you're not confused. Airplanes come from the manufacturer with what they call a basic empty weight. That is calculated and put into the manual. Each aircraft has its own specific manual, and it's only good for that specific plane. Those numbers are already here on our chart. Aircraft weighs 2,100 pounds. Its arm and moment are already figured from the manufacturer. Our arm, we figure that there is a line that is put in there from the manufacturer called the datum line. That's where we take all of our measurements from. Basically, if you were to take and balance this plane on a post like a seesaw, from the manufacturer, the distance of where the post is where that plane would balance. As we add or take away weight, that changes, which is our center of gravity range. This is the ability that we have to move this post in order for this plane to balance. So anything behind the datum line is a positive arm. Anything in front is a negative arm. The arm is the distance in inches from the datum line to each station. That's what we call each position. So front passengers would be 85 inches behind the datum line. Passengers, back seats would be 121 inches. Cargo would be 150 inches. And our fuel is 75 inches back from the datum line. So in order to figure our weight and balance, we have a chart in our POH, our pilot operating handbook for the plane. It has a chart and a graph in here that once we get our numbers figured, we have to make sure that we're inside this range here. So say we have two people in the front. Together they weigh 340 pounds. And that's 85 inches behind the datum line. So in order to get the moment, we have to multiply 340 times 85. That would give us 28,900. Then say we have some rear passengers, and say our rear passengers together weigh 350 pounds. So we'll put 350 right here. That's 121 inches back, so we multiply the weight times the arm to get our moment. That would be 42,350. So 42,350. So then say we have 80 pounds of baggage. We multiply that times the 150 because that's the inches back once again. So that gives us 12,000 pounds. And then our fuel, we have to do our fuel in pounds. Fuel weighs 6 pounds per gallon in this type of plane here. So we'll say we have 450 pounds worth of fuel. And that would give us 33,750. All right, so once we get all of these totaled up, to find our new arm, which our new arm would be the balance point, like a teeter-totter, that the plane would sit on. So we add up this column and we add up this column. And once we get those totals, we get 3,320. And then 281,430. All right, so once we get these two total numbers, we will divide our moment by our total weight to get our new arm. So our new arm would be 84.8. So 84.8 being our new arm means that our new balance point is 84.8 inches back, which our front passenger is at 85. So we would move our balance point, which was 78.3. So we moved 78.3 to 84.8. Just moved our balance point backwards a little bit. So then we would double check and cross-reference our chart here. Take the total weight of the plane loaded and our new arm distance and connect those two up, and we're right here inside of our envelope, which means that our plane would be balanced and we would be safe to fly. That is my demonstration of how to find weight and balance for an aircraft. Thank you.